Welcome back to Machinist Made. Today we are going to go over how to tell Fusion itself what datums we are machining off of. Basically, we're going to set up our Cartesian coordinate system or our work offset location. So in Fusion, up in the top left hand corner, you'll see a setup tab, and I've got my tiles turned on. That way I can hover over anything and you can get a brief description. If you want to read it, you're more than welcome to pause the video. But we'll start by clicking on setup, and then you see this screen will appear. Fusion will automatically recognize the setup type that you want. You see operational type right here. It's automatically going to default to milling. There's other options within here, but we're going to stick with milling for today's example. Outside of that, we've got our work coordinate system, or our WCS, or our work offset in CNC terms for the machine. You'll notice that we need to mill a hole inside of this quote-unquote block of material. Well, right now we can't get to the side because our Z, or our spindle, will be coming in from the side of the machine. Keep in mind, the spindle on any machine is your Z axis. We need that Z to be pointing straight up. There's a couple ways to do this, but my preferred method is to go to where it says orientation. It will always default to model orientation. You need to change that to ZX plane. Now, if you drew your part correctly, and I use the term correctly very loosely here, if you drew your part from the top-down view, you're going to be fine. But if you drew your part in any other orientation, or you're importing a model from, pick a source here, right? Then it may not be drawn in the correct orientation. You will have to do this. So again, orientation, Z axis plane, and X axis. We click on that, then it's going to give us some options down here. So our axis for our top is the top of our part, and X axis in this scenario is correct, but we're going to go ahead and identify it with this plane. We can choose any plane that we want. Outside of that, there's really nothing else you have to do in this tab of setup. One thing you will want to do is select some stock. So again, Fusion defaults to from previous setup or relative size box. Well, we don't work in relative. Machinists don't work in relative. We work in actual material sizes, and we usually know what size material we're going to use. So we'll select fixed size box, and it tells us this model is 3 inches in X, 3 inches in Y, and 1 inch in Z. Now, if you've got a perfectly square block of material, this works out wonderfully and it'll make your day. But if you don't, you will have to machine the outside of this part as well as the internal bore. The way we make these changes is as simple as you're probably thinking that it is. We just add material. Most material comes in 1/4 inch configurations. So when you're talking about material, you go 3 inch, 3 1/4, 3 1/2, 3 3/4, and you kind of work up from there. So pretty much all material works up in 1/4 inch increments until you get up to larger sizes, and then they actually start working in eighths. So if we're holding on to a 1 inch block thickness wise, we need some material on there, right? We got to face it off. We've got to hold on to something. So we are going to add material to our Z height. Now again, 1/4 inch increments gives us a 1/4 inch worth of material to play with. See from your side view. Fusion will automatically center everything up. Now, a lot of machinists, including myself, prefer to work off center line, but this is not true when it comes to the thickness of the actual part. We want to hold on to as much as possible, because in the world of production, time is money, and a customer does not want you to waste their money. So we save the money by increasing the part per hour we can produce, or decreasing the cycle time per individual part. So in our Z height, we'll go to model position, offset from top, our offset amount, my preferred offset amount, is 20 thousandths. The reason for this is from my experience, and you can find some other people that may or may not have the same experience. Material does not come in perfect from material suppliers. It's rolled around on the truck. Material is slid across it. It may have scratches and grooves cut into it. The easiest way to mitigate this is to always do a face cut. Now, if your customer doesn't care and they don't call for a cleanup, Mark, hey, go for it, But I want a flat datum surface to work off of. So I will always take a minimum of 20 thousandths for a face cut. And this round up to nearest, I never use it. Once we're done in this tab, we go over to part process and we change our program number. Some of you might get that reference. So we create a program number, and then we create a program comment. This is tutorial 7. I like to name my program comments after what the part is actually called on the print. Sorry, this is actually tutorial 6. Outside of that, we have to select a machining work coordinate system. If you leave it at 0, the machine will default to G54. Modern machines will anyway, like Haas's and your more modern FANUC controls. They wake up in G54. That's what they're going to use. But we want to make sure we do designate it. So 1 is G54, 2 is G55, 3 G56, 4 G57. Again, these are just work offsets inside of a control. Now, some machines just say work offset 1, 2, 3, 4, 5. I work on more industrialized equipment, so they're a little more specific to the general industry. Once we've got that done, we simply just click OK. You'll notice that our Cartesian coordinate system, or star globe, or origin point, stays in the middle of our part, and now we would be ready to machine. And that concludes today's tutorial on a simple part setup. As always, make sure you like and subscribe, and leave a comment down below letting me know what you actually think of this video. Hope to see you again.